We formally open the meeting and say welcome to everybody, and welcome to those in the hall and welcome to those online, and a very big welcome to Dr Beckie Port. You're going to have to tell us what you're a doctor in, Becky.
Okay.
She's the head of research, communications and engagement at Parkinson's UK, and is here to have a very interactive session with us, so to answer any questions we have and see where that leads us, I believe. So let's hand over to Becky and you can talk us through how you're going to run the session first.
Yeah, no worries. So yes, if anyone has any questions, chat's really easy for me to see because I'll actually be watching the chat. So if you've got a thought and you just have, oh, I want to hear about this, feel free to put it in the chat if you're at home. If you don't like using chat or just don't know where to find it, feel free to put your hand up, and I can see those. And then if you're in the room, I'm going to be asking Rose if there's anyone with hands up, and I don't mind being interrupted, so Rose, if somebody does put their hand up, do feel free to wander over and I'll see the camera moving and hopefully be able to take questions. So I have some things that I thought people might be interested in, but when I've been to a branch talk before, the longest I've ever spoken was for 3 hours. We had 2 breaks. But obviously, I can't promise that there will be tea and biscuits for all of you because I don't know whether you've got biscuits at home. Half the group is at home, so I don't want to promise anything if I can't deliver it. And I'm not going to go on for 3 hours. Don't worry. There is so much I could talk about. I'd rather talk about things you are interested in. So at any time, if you want to know anything, if you've heard something in the news, anything you like, just feel free to either put your hand up, pop it in the chat, and we'll go off on tangents, talk about what you're interested in, and I hope it'll be quite enjoyable. No presentations today, so you've got nothing to stare at and try and read, just me and everyone else that's on the call. So yeah, that's how we're going to run it today. So I hope that sounds like a good plan.
Sounds like an excellent plan.
Thumbs up. Thumbs down. Oh, there might be voting as well. If I think that everyone's falling asleep, I will get some voting going on, and we'll, I don't know. Right. So yes, I work for Parkinson's UK. I have worked in the research team for 8 years now. I come from a background as a researcher. I used to work in a lab in Birmingham, University of Birmingham, and I was studying viruses that cause cancer. So I've got a bit of a background in viruses and moved over to Parkinson's UK in a long time, 8 years ago, whenever that was. Forget what year you're in nowadays, don't you? Years don't mean anything. So yes, I'm going to talk about everything Parkinson's, things that you may be interested in. If you're bored, feel free to do this. We'll move on. How about that? So let's start off with what Parkinson's is. Now, obviously, everyone here in the room, online, knows exactly what Parkinson's is to them. We often hear it being described as a progressive neurological condition. It's to do with the type of cell that produces a chemical called dopamine. So people have often heard of dopamine, might be more familiar with the word levodopa because that's the drug that we use to treat Parkinson's. Now, does anyone know why we use levodopa as a medication rather than dopamine if it's the dopamine that's missing in the brain? Anyone ever thought of that?
It's because the levodopa, they can cross the blood-brain barrier.
Yes, gold star for David. That is exactly the reason. So levodopa can get into the brain, whereas if we gave dopamine as a tablet, it wouldn't get into the brain. It's too big, and there's this barrier that protects the brain from viruses, bacteria, anything nasty that might be floating around in the rest of your blood. We don't want them getting into the brain. Brain's very precious. So there's this barrier called the blood-brain barrier that stops big molecules and also anything nasty getting into the brain. Dopamine is one of those big molecules that can't pass through it. However, levodopa is a smaller molecule and it gets into the brain, cells take it up and they produce dopamine. So that's why we use levodopa to treat Parkinson's. Now, levodopa was first developed in the 1960s, and people often say that we haven't had anything new since then. Now, I always challenge this because when people started being given levodopa in the 1960s, they just couldn't take it. It was absolutely horrendous. They got awful nausea and couldn't take enough of the drug to actually make a difference to their movement symptoms. And it's all of the developments that have gone along with levodopa since, things that we combine that drug with. So Sinemet isn't just levodopa, it's got other things in that drug that help the brain to make the best use of levodopa and to stop it being used in other parts of the body that cause the side effects that come with Parkinson's medications. Now, when it's in the last 10 years or so, maybe about 15 now, there's been a shift in how we understand what Parkinson's is. Up until 10, 15 years ago, people were concentrating only on the motor symptoms of Parkinson's, things like tremor, slowness of movement, freezing, those types of symptoms. And all the non-motor symptoms were kind of by and by, they weren't part of they weren't at the forefront of people's minds, which also meant nobody's really doing research to address them. But that's changed a lot, and now we really know that Parkinson's is a movement and a non-movement condition. And some of the non-motor symptoms actually give us a lot of insight into what's going on that causes Parkinson's. Now, most of the time, we don't know what causes Parkinson's. We cannot go to somebody and say, this is what caused your Parkinson's. For very few people, we can say it's most likely because you have a genetic change. There are risk factors, genetic risk factors that increase the risk of Parkinson's, but even those are not causative. They don't always cause Parkinson's. You can have a genetic risk factor and never go on to develop Parkinson's. We know that there are environmental causes or environmental risk factors. They don't cause Parkinson's. Not everyone that's exposed to the environmental risk factors get it, but things like pesticides, exposure to certain chemicals that are used in cleaning products, these things are known to increase the risk of Parkinson's ever so slightly. But going back to those non-motor symptoms, because some of those give us an insight into where Parkinson's might be starting. And whilst we say that Parkinson's is a neurological condition, researchers now think that not all people, Parkinson's starts in the brain. And for some people, it may start in the gut. Now, has anyone ever heard of this idea that Parkinson's might start in your gut and travel to your brain? We've got some nods.
Yeah.
Got some shakes. Got a nod from Francis. Got a couple of nods in the room, I think. So the idea is, in Parkinson's, we're not very good at diagnosing Parkinson's. We've got no definitive diagnostic test, no blood test that you could do and say, yes, you have Parkinson's. We diagnose Parkinson's based on the symptoms people have and how they are progressing. So we have specialists that give diagnoses, but it's only when somebody passes away and gives their brain to science that we can be 100% sure that they actually had Parkinson's. And you may have heard of the Parkinson's Brain Bank. So if you are interested in donating your brain to science, we can facilitate that. They've already got mine signed up. Can't have it yet, but they got it signed up. When they have a look at inside the brain, when people pass away, they find these little sticky clumps of a protein called alpha-synuclein. Now, these clumps are called Lewy bodies, and you may have also heard of Lewy body dementia. It's a condition very similar to Parkinson's, but where dementia and memory problems precede movement problems. But otherwise, mostly the same things going on. It's just the order in which symptoms appear. Now, alpha-synuclein, and actually, before I move away from the brain bank, some people that have been diagnosed with Parkinson's for many years have actually given their brain to science. They've looked inside it and found a huge tumour. Didn't even have Parkinson's, just had a tumour that mimicked the symptoms of Parkinson's. So there you go. Sometimes it's not Parkinson's, but most of the time it is. Whilst we're not definitive in our diagnoses, we're quite good at them by now. So yes, this alpha-synuclein protein, this protein that we find built up inside the cells, inside the part of the brain that produces the dopamine that's really important in Parkinson's, this alpha-synuclein protein is believed for some people to start becoming mischievous, start becoming sticky and misshapen in the gut. And when it does, there is a nerve that travels all the way from the gut up the spine into the base of the brain, and that alpha-synuclein can travel up that nerve and into the part of the brain responsible for Parkinson's, which is called the substantia nigra, in case you have heard that being batted about. So for some people, the earliest symptoms that they get are things like constipation. The problems haven't yet migrated to the brain, and they get constipation, and then as the changes move up the brain stem, it hits parts of the brain just next to the substantia nigra, just underneath, that are responsible for things like sleep problems and anxiety. These non-motor symptoms are actually telling us, no, actually Parkinson's is not starting in the substantia nigra, it's moving there. So another early symptom that some people with Parkinson's have are changes in their sense of smell. And your olfactory bulb is kind of connected to the nerves in your nose, and it kind of sits kind of eye level, more forward in the brain than the substantia nigra, that part of the brain responsible for the movement symptoms of Parkinson's. And for some people, we think that changes in the sense of smell, again, the alpha-synuclein protein seems to be responsible, and that seems to be the protein that's moving from the olfactory bulb back towards the substantia nigra. Once it gets to the substantia nigra and starts impacting those dopamine producing brain cells, that's when we see the movement symptoms of Parkinson's, and that's when people get diagnosed, not because they have constipation or smell changes. People can have those and never develop Parkinson's, but yeah, we're learning a lot about how Parkinson's affects the brain and where it starts based on understanding the symptoms. And you can imagine the last 15 years just opening our understanding of the condition to include all these extra non-motor symptoms has really changed how we're both understanding how we might stop Parkinson's in the future, but also understanding how we might treat all these non-motor symptoms. So I'm going to pause there. Have we got any questions anywhere? Anything that anyone wants to ask?
Anybody online, first of all, want to ask the questions? I've got a question. Okay, well, a question in the hall. Somebody like to take the camera. And I can't remember. It's Marion. Yes. Can you hear Marion?
Hello.
Yes, I can hear Marion.
Hello. With your research that you've been doing, and the fact that this is for my husband Jack, not for me, and it passes through, he is suffering terribly with a lot of saliva.
Right.
And we tried lots of different medications and different doctors, and nothing seems to help. In fact, it's getting worse. In your research, have you come across this, and what would you suggest?
Right. In my personal research, no. Obviously, I'm representing quite a lot of researchers working on everything, even those not funded by Parkinson's UK. It is a common problem. A lot of people with Parkinson's do experience problems with saliva and build-up and drooling as well, because if it's not being cleared, that could be an issue. Now, there's different medications that people can take to reduce the amount of saliva that they produce. There's even things like Botox that can help tighten things around the mouth and things to try and encourage that saliva to stay in the mouth and be swallowed. Perhaps the most related research that I can think of is we know that, so your brain, that substantia nigra, when we talk about dopamine and about movement, people always think about moving your arms, moving your legs, handwriting, things like that. But actually, the movement signals are responsible for everything from like swallowing as well. So if you've got less dopamine and your brain isn't communicating effectively about all types of movement, it does affect swallowing. People can forget to swallow. So there's a research, and I forget where they're based, but there is a possibly even active clinical trial that you might be able to find now, where they're using a device that basically it vibrates or gives a signal, and you're trying to train people to swallow every time the device goes off. Now, it almost becomes like an extra sense. You don't become aware that it's vibrating, but every time it vibrates, you swallow. So things like that might be able to help people. So drugs and things, they all come with side effects, but actually what can we use in technology to help people to overcome some of these symptoms? So anything that I mentioned that might be an active clinical trial, there's a way to find it. On our website, we have something called the Take Part Hub. You can type that into Google, it will come up, or just go to our website, go to research and get involved in research. Rose, I can send out a link in an email as well, just so that you can send that around to people. But yeah, on the Take Part Hub, all the clinical trials that are currently looking for people to take part are all listed on there, and there's something for everyone. Like, even if you don't have Parkinson's, doesn't matter what age you are, there is something for everyone on the Take Part Hub that people can do to help research, whether that's just filling in a survey about symptoms or taking part in an actual trial of a new device or tablet. It's all on there. So I will try and remember to look up the swallowing trial and send that to Rose. But in the meantime, if anyone's looking for opportunities to take part in research, Take Part Hub is where you need to go. So I hope that helps.
Yes, thank you very much for looking out. Thank you.
No worries.
If you could remember to send the link, we'd appreciate it.
Yes. Yes. One sec. Pen. Swallowing. Okay, I've got that. No worries. That's not going anywhere. So.
I think Andrew put a question in the chat.
Ooh, chat. Yes, I said I was going to keep it open, then I didn't. Are there any treatments other than chemicals? Yes. So we know that people are taking lots of different types of medications, often combining things where you take one medication, then you take other medications for the side effects of the first medications, and then you take other medications for the other symptoms, and it can become a bit of a nightmare. So we know that people have told us that. So we now have a grant scheme at Parkinson's UK. So the way that we fund research is through grants. Researchers apply to us, we give them money. It's called a grant. We've got a whole funding stream specifically about non-drug related research. So things that are potentially actually a lot quicker to get through the research stages, because they don't involve taking maybe a risky new drug that's going to have side effects. Quite often they're technology based, and trying to promote more research in that area. So things like wearable devices that can help with swallowing, through to stimulators that can help with bladder incontinence, using electrical stimulation through the skin. There's all sorts of research going on looking at the potential of using things like your Fitbit or your smartwatch, your Apple Watch, to help improve clinical trials, through to things like exercise therapy and cognitive behavioural therapies, things like that can be really important for keeping people mobile and making the most of your muscles and everything. So one of the theories is that as Parkinson's affects those dopamine-producing brain cells and reduces the brain's ability to communicate about movement, if you strengthen your muscles, they need less communication to get working. So if you go out and do exercise, if you can do strength exercise as well as cardiovascular fitness, which is all of the exercise is good for everyone, but it's good to get a whole range of things, and stretching, because obviously you want your muscles to be working well. These types of things can actually help the brain better communicate with your muscles. So that's one of the reasons why we think exercise is so important. Another reason why we think exercise is important is actually when you do exercise, your brain produces lots of lovely chemicals that have protective effects on brain cells. So the more you exercise, your brain produces these protective proteins, and then that might even be able to slow down the progression of Parkinson's. The reason I can't say it does is because it's kind of frowned upon to tie somebody to a chair and prevent them from doing any movement at all to do the clinical trial to actually test whether exercise is effective. Everyone moves, and that movement in general produces some level of chemicals in your brain. But yeah, we think that the more exercise you do and doing it at the highest level that you can. So we're not suggesting everyone goes out and does the 3 Peaks challenge, no, but at the level that's right for you, if you can get out and do more exercise, we do think it does have an effect on symptoms of Parkinson's and might even slow progression. So what about dance? Dance is a great one, yes. And we even have a partnership with the what's the ballet? I've forgotten their official name, but we have partnerships with England Ballet, because obviously you have to be flexible for ballet, and people with Parkinson's doing ballet for the first time through their local groups in Bristol, I think. So yes, any type of dance, doesn't have to be ballet, it can be, I don't know, waltz or I don't know, modern dancing. Anyone fancy some break dancing? I can't honestly say I'd be able to get off the floor if I tried that, but any type of dance, yes. Anything that's enjoyable, basically. If you do exercise that you enjoy, you're going to get out there and do it more often, and it's going to have longer beneficial effects. So no point in doing something you hate. Find something you enjoy and make friends doing it. That's the best type of exercise. Cool. Any question? Oh, we have a hand raised.
Yeah,
This is excellent.
That's me.
Sorry, I'm so engrossed. I'm forgetting my job. Sorry.
Yeah. So, well, I've got a number of questions. I'll just ask one for now. So there was a couple of years ago, we received something from Parkinson's UK about some research doing into falls prevention, and it was something about a handheld device, and it was something about stimulating the cranial nerve. Vagus nerve.
Vagus nerve, yes.
I just wondered about into that research.
I think that's still ongoing. I don't think they've reported on it yet. So the vagus nerve is actually the nerve that travels from your gut up to your head. So that's the highway that alpha-synuclein naughty protein takes up into your brain. But yes, I haven't actually recently looked into that project. I would have to say I think it's probably not written up. One of the things with research is that you do a trial, you then have to analyse the results, then you have to get them published. Now, sometimes that can take a few years. But actually, if you take part in research, quite often you can get like insight into what's going on and get updates on those programs. So if you take part in research, it's always good to keep in touch with the researchers because they can give you the latest information and tell you when they're expecting to publish and things like that. So that's also a benefit of taking part in research. The other one is you might find your husband. I took part in his clinical research study. Found my husband. He's called Johnny. Was doing stroke rehab. I was a control person for somebody my age at the time who had a stroke. And I asked him out. I know ethically it's a bit dodgy, but I asked him out, so I think it's okay. Yeah. I said, "Do you want a coffee?" He said, I don't drink coffee. I was like, "Tea?" So another potential benefit of taking part. No, please don't harass our researchers. I am actually kidding. I'll go back to head office and yeah. We've got a branch that's going to researchers and asking them for dates. Anyway, so I'm going to assume that the hand is down in the room.
Yes, it is. It is.
Yes. So let's have a bit of a vote. Now I can't see what's going on in the room, so you might have to, I don't know, give me an indication. Yeah. But I've got a few things on my list that I could talk about. So, and if there aren't questions in the room, let's have a bit of a vote about whether you want to hear about stem cell therapy, or maybe cannabis.
Oh.
Hands up for stem cells.
So I want cannabis.
Everybody wants to hear about
cannabis. Cannabis always wins. Okay, don't worry. I'll go back for the stem cells. We'll put that up again in a second. So, cannabis, yes. Right. Before I get started, I'm not going to be suggesting that you go out and find some cannabis. That's not how this is going to go. Sorry. Obviously, you're all grown people. I can't control what you do. But the recommendation from Parkinson's UK should not be that you go out and find somebody that can supply you. That's no. Right. What I am going to say is, in cannabis plant, in the plant that's illegal to grow, there are lots of different types of chemicals. It's a natural plant. It's not made up of one thing. But the two most important chemicals in cannabis are called THC, which is the psychoactive one. It's the one that's illegal, and that one gives you all your fun effects. That's why people take cannabis. And then you've got your CBD, which is not psychoactive, and in lots of different studies there seems to be some beneficial effects for a variety of different conditions. And when it comes to Parkinson's, there have been some very small studies looking at taking just cannabis, the whole cannabis, which includes the THC, and there's some mostly anecdotal evidence that it may help some people with certain symptoms. Now, unfortunately, there aren't very good clinical trials proving anything to do with cannabis. But for CBD, so the legal bit of it, the bit that you can go down to Holland Barrett's or, I don't know, Superdrug and buy in little capsules, that's absolutely ridiculously expensive and also not quite sure whether it would work. But you can never be sure because it's a supplement. The difference between a supplement and a drug is controlled, supplements are not. So you can never actually be sure what's in your supplements. But anyway, the CBD that you can go buy in a supplement from anywhere on your high street, we are currently funding a clinical trial to see whether it could help with hallucinations in Parkinson's. So something that comes from cannabis, we think might actually work to reduce hallucinations that quite a few people experience in Parkinson's as it progresses. So we're doing a clinical trial. It is active. It's not recruiting at the minute, but it is about to reopen for people to take part. For people that experience hallucinations, I can see there's a hand up, so I will come back to the room in a bit. So the idea is that what you get on your high street, cannabidiol, your CBD tablets and capsules and drops, they're very, very weak and very expensive. And actually the levels that we want to study in a clinical trial are a lot higher, and we want a much purer product at a better quality. And to do that, you have to actually manufacture your own supplement. You can't just rely on something from Holland and Barrett's. So this clinical trial is using a very high dose of CBD oil that's packaged up in a capsule, and people who experience hallucinations are taking it to see whether it improves that symptom. And yeah, if anyone's interested in that, keep an eye on our Take Part Hub. It's not currently recruiting, but we expect it to be recruiting sometime in the future. So I can see there's a hand up in the room. Let's go back to the room. You're getting a walkabout.
Yes.
I'm interested in laying out a situation that you've just brought up about the night visions. Mine are thoroughly enjoyable, and I'm going to be really upset if somebody takes them away. It involves members of my family that I've seen for a long time. The first time was my wife, and she stuck her head around the corner and said, "It's 8 o'clock, you're going to be late for work," which I retired from at night a long time ago. And I was frightened until I realised that she walked through the door and she finished waking me up. So I went back to sleep and I wasn't troubled. So if you do find anything that
He doesn't want it.
No, enough. Yeah, we only want to treat the symptoms people don't want. We don't want to take away things people are enjoying.
One other question while you're facing this way. Have other people found that with Jack, his speaking is much quieter than it used to be?
Yeah.
Is that typical?
Yeah.
Yeah, that's a well, and actually there's specific training courses you can do, speech and language therapies that are particularly for Parkinson's. Again, it's all to do with the fact that it's movement based. Speech is movement based, and as you have lower levels of signal to do movement, it does affect everything, including speech. So yes, there's LOUD is the training, all capitals LOUD. That is one of the training courses people can do about speech and language.
Yeah, I was going to say, Becky, that's not unfortunately available on the NHS in this area. So it was at one stage. I think David Stanfield, have you been on LOUD? You've been on
No, I haven't.
You haven't. I think some other people in the branch did go on it at one stage. There was some funding, but it's not available on the NHS. That's the problem. Certainly not in this area.
Yeah, the other thing is, again, it's coming back to devices and things. So there was an app developed a few years ago now, actually isn't available, but to do with, it would record you and then play you your voice back and show you how because people think they're speaking loudly. So yeah. I've heard many people describe it. They think they're almost shouting, and actually what's coming out is very, very low. And after practice, things like singing can help. So things where you're encouraging people to to what's it called, to
Project.
do that with your voice, that project it, thank you. Those can help, and being understanding that even though you think that it's really loud, it's not, can help people to boost their voice even further.
I would
So
say,
yes,
Becky, sorry, I would just say that you can get a referral to speech therapists locally who can help to a certain extent. So I would suggest that. And also, if you're interested in singing, we have a singing group in the branch, which is, say again? Doesn't matter. If you fancy it, we've got a group.
And we had that slide.
Yeah, we did have a speech therapist to talk to us a few months ago. It's online still if you want to. It was, well, yes, David Stanfield will tell you about the singing group. Go on, David. Yes.
The next session is tomorrow. If you're free tomorrow morning, 11 till 12, Kiswell Green, St Albans.
there you go.
Yes, yeah.
I'm drumming up support for you, David. Hopefully you'll have a few more members. So yes, singing, it doesn't matter. Yeah, it does not matter what you sound like. It's all about improving the like helping you with symptoms. So yeah, if speech is becoming an issue, do feel free to take part in singing activities, and yes, do get referred, because there are people out there that can help, and there's even things like apps and things that can basically play you back your voice and over time help you improve it and give you like a score of how loud you are, and then you can work on it. Right, let's.
Can we have another question from the room?
Yes. Yes.
With regards to the CBD trial, my mum, who I'm looking after with Parkinson's, she's very nervous of any doctors or anything like that. My mum is suffering from hallucinations at night and she's exhausted in the day. If we could sign up for that trial, how would we give feedback? Because my mum probably doesn't remember what's happened in the. Would it be a case that I would have to stay with mum and monitor her overnight to give the feedback? Do you know? I mean, obviously you said it's not open yet, but have you any idea how it may work?
Yes. So the best thing to do will be to speak directly to the researchers. So the people that are recruiting, they share their phone number, and then you can ring them up and say, look, I want to know more, what is going on. But they're looking for, so they do a baseline assessment, and they'll ask how many hallucinations people are experiencing over a period of time, and then throughout the trial there'll be certain assessments that people go for where they'll speak directly to a researcher or fill in a diary, and that's what's used to assess whether the drug's working. There are other, so we're funding not just one clinical trial about hallucinations, but a second one, which is actually of a repurposed drug called ondansetron. Now, ondansetron is already available as a drug that people take. It's used for sickness in chemotherapy. So when people are taking chemotherapy for cancer, one of the side effects is sickness, and ondansetron was produced to help with that. But it seems to have a side effect, or it seems to have a beneficial effect in Parkinson's, and may also help with hallucinations. So it's called Top Hat, which stands for Trial of ondansetron in Parkinson's, and I can't remember, but Top Hat. Also, it's going to be, I think I got permission. Okay, this is embargoed, but meh. Look out for a something in the Daily Mail over the weekend. I think that's going to mention Top Hat, and other clinical trials that are currently looking to recruit people. And was it Sunday Times or something? I think they might also be covering Top Hat. So there's various things about Top Hat coming out in the next few days, actually. So yeah, they're looking to recruit right now, and because they started during COVID, they've been a bit delayed in getting going. So they're keen to have people get in touch. And as I said, researchers, lovely people, will always give you the information you need. So if you think, oh, I might be interested, but I don't know, feel free to get in touch with them, because they want to encourage you to take part if it's right for you, and in this case for your mum. So yeah. Have people heard of other repurposed medications for Parkinson's?
Yeah, my mum was given an epilepsy medication as well, but that didn't work at all, to try and get her to sleep at night. But basically it knocked her out so much I couldn't wake her up in the day. She was like a zombie. So even halving it and quartering it, and it just was a non-starter. So we had to give up on that. Yeah.
Yeah. Well, some drugs seem to have, because obviously we design drugs for one thing, we test them for one thing. There's tens of thousands of drugs that are licensed for different conditions for people, but they normally have only been tested for one, maybe two different conditions. Now, do people heard of the word repurposing? So this idea that you take a drug from one thing and use it for another. The classic example is Viagra. Viagra was originally invented as a heart medication, and they were giving men Viagra as part of a clinical trial, and they went, that's a interesting side effect you've got going on down there. I wonder whether we can market that. And that's where Viagra came from. So yes, that's essentially the idea behind repurposing, is that you develop a drug, you think it's going to do one thing, and then you actually work out it could do lots more. Don't worry, not many repurposed drugs end up doing anything down there. Just putting people's minds at rest before they take part in a clinical trial expecting some anyway. So any questions, anything that people want me to or shall I go for it?
Sorry. What is the most exciting development, would you say, at the moment, in your opinion, in Parkinson's research? With the most.
Oh, good. This takes me back to stem cells anyway. So yay! So my research, so viruses. When I was working in the lab, the idea was that the virus was getting into a type of stem cell, and that's how cancer was starting. That was the idea. So I love a stem cell. Right. Do people know what stem cells are? Shall I start right from the start?
Yeah. Yes.
Start from the start. Right. Okay. So a stem cell is the basic cell that makes up everything in our bodies. So it's the cell that's got no particular type, but can become any type of cell in the body. Now, the perfect stem cell is what you get when you have an egg from a woman, sperm from a man. I don't know why these things keep coming up, but yeah, we've had that twice now, but sperm. And that one cell that comes from those two meeting is the perfect stem cell. That eventually becomes everything in an entire human body. Now, obviously, when you're an embryo, stem cells are very important, but actually in adults, we also have stem cells. They're called adult stem cells, easy peasy. These are not quite as good as the original embryonic stem cells that become everything. Adult stem cells are found in lots of different types of organs. You have heart stem cells, you have blood stem cells, we even have brain stem cells. And the idea is that if there is damage, they can repair that damage. There's liver stem cells. If you go out and you decide, actually, we haven't talked about the fact that I talked about some of the things that increase risk of Parkinson's. Sometimes I also talk about things that decrease your risk of Parkinson's. One of those things, if anyone cares, is actually hops in beer. And there's some evidence that the antioxidants in red wine might also decrease risk of Parkinson's. So normally I've spoken about that, and then I say, well, if anyone decides to go out on the piss after this talk because they heard me saying something about beer and wine, and tomorrow morning your liver will be regretting that. It will be your liver stem cells that get activated to repair the damage that is done. Now, that's all well and good. We've got brain stem cells, not very active. They're not going to really do very much in the way of repairing the damage that Parkinson's is doing. But researchers back in 2011 worked out how to make a basic stem cell into a dopamine producing brain cell. So normally the body is responsible for all of this, but actually in the lab, researchers took some stem cells and worked out exactly what type of chemicals and proteins you have to put on that cell to make it into a dopamine producing brain cell, the type that is lost in Parkinson's. So if we know how to make new cells of the type that are being lost, would it be possible to potentially put some new brain cells back into the brain and reverse Parkinson's? That is essentially the whole concept behind stem cell research. And we are making progress towards that not being science fiction, that we're actually thinking that could be possible. And there are clinical trials that are meant to be starting in Sweden and Cambridge. They're coming together, researchers in Sweden, researchers in Cambridge, doing a clinical trial called STEM PD, which is essentially based on this idea that if you have a load of stem cells, you transplant them, you do surgery, it does involve brain surgery, obviously, they're not going to get there by themselves. Could we put new cells back into the brain, encouraging them to integrate and potentially reverse the symptoms of Parkinson's? There are various trials ongoing. There's one in America, even using cells that have come from somebody originally. So now, you may be aware that if you have a transplant, so if you had a heart transplant, one of the things that you have to have for the rest of your life is immunosuppressants, because that heart wasn't originally in you, and your body goes, that's not part of me, and fights it. So immunosuppressants are needed to make sure you don't reject a new organ. Now, if you're given new cells and they haven't originated in you, they may be under the same, they may also be attacked by your own cells. In the brain, fortunately, that doesn't happen as much. There are actually fewer immune cells in the brain, but it's still a risk. So one of the ways around having to take immunosuppressants for the rest of your life is if a researcher comes up to you, takes a bit of skin, makes some stem cells from those skin cells, so turns the hands back on time, turns them back into stem cells, and from there turns them into brain cells. And we can actually do that as well. So the clinical trial that's happening in California at the minute is doing that as well. So actually taking cells from a person and turning them into new brain cells and giving them back. So that's quite cool. So that's why I like a stem cell. Now, obviously, there's a way to go to understand how safe these things are, because obviously you're putting new cells that have got all these abilities to turn into different types of cells. Are they going to remain as dopamine brain cells? Are they even going to survive the process of being transplanted into the brain? Are they going to integrate and produce dopamine? Lots of questions left to go. So I normally talk about stem cells, and then I also talk about some of the other bits and pieces that's happening right now. And the other big thing in Parkinson's that I think is really going to change not only how we develop new treatments and come up with ways to slow Parkinson's, because obviously we can't do that at the minute, but also to change how we try and treat people, is the idea that Parkinson's is not one condition. Now, if you think of breast cancer, it wasn't that long ago that when people talked of breast cancer, we said breast cancer, one condition, you have breast cancer, that's the diagnosis, end of story. Now, you might be aware that that's not the case. So people have things like BRCA positive breast cancer, different types of breast cancer that we know respond differently to different treatments. Some of the treatments for one type of breast cancer do not work at all on another type. It really depends on what type of breast cancer you have. Now, that's the same in Parkinson's. There are different types of Parkinson's. We just haven't worked out exactly what they are yet. So we know some types are faster progressing. We know some types are more related or are more often cause motor symptoms. Some types more often cause non-motor symptoms. Things like that really change how we would need to address giving people treatments. Because it's likely that the reason that one treatment works for one person and it doesn't on another person, and there's so much variation, is that people have different types. And if we understood, well, that type of medication works best there, let's try that first, people wouldn't have to go through the process of finding what works for them. It also means that researchers, when we're trying to work out what the hell is going wrong with the cells in the first place to cause them to die and to then start this snowball effect that is Parkinson's, where it kind of progresses from one cell to the next and causes more cells to be lost, it's probably different things. It's probably not the same underlying reason why one cell dies in one person and another one dies in another. For some people, it might be related to the batteries that power all of our cells. For some other people, it might be related to how cells get rid of their waste. And if we can understand that, and if we could find a test, and researchers are moving towards the idea of doing diagnostic tests, it may be possible that we actually have a lot more success in clinical trials. And some of the trials that have been through in the last 10 years, things like GDNF, you may remember seeing GDNF on the BBC. There was a documentary. It didn't meet its endpoints. It wasn't a successful trial, but for some people in that trial, it was game changer. They think for some people, it reversed the damage that was being done by Parkinson's in the brain, but only for some people. And if we actually understood why and put the right people forward for the right trials, all of a sudden we may have a treatment that slows down Parkinson's. So that is kind of the other thing that's going on at the minute. Now everyone looks like they might have had enough of me talking now.
Yeah, we have another question here.
Yep, go for it.
Sorry, I've just got a couple of questions. On average, how long does it take for a trial? Because when you're producing medication, I know they sort of say on average 13 years, but what is it for a trial, that you know about? What is the average time scale?
So clinical trials have different stages. If you invent a new drug that's never been taken by people before, you have to do a very early stage 1 trial where you give it to a handful of people and basically check it doesn't kill them. That's the ins and outs of it. You can normally do that quite quickly. You can give the treatment to somebody, they don't have the condition or anything, you're testing whether it's got a damaging effect for humans. Assuming that goes well, the next stage is a phase 2. This is where you continue to do your safety assessments, but you may give it to the people with the condition you're trying to treat for the first time. Now, a phase 2 study, the main aim is safety, but you're also trying to assess whether it looks like that drug has the effect that you want it to, has the benefit that you think it should have. Now, for Parkinson's, it's not as easy as maybe cancer. If you give a drug for cancer, measure the tumour size, give the drug, measure the tumour size, it's bigger or smaller, Bob's your uncle, you've got an output. Parkinson's, symptoms change day to day, hour to hour. We don't have a measure. You can't just go, oh, that's how big it was, and now it's this big. We don't have that. We don't have ways of measuring Parkinson's apart from how it affects people's symptoms, which is very, very hard to measure. Also, Parkinson's is a very slow progressing condition. So particularly when you're looking at a treatment that might slow down Parkinson's, it then means that you have to do your trial for a very long time to actually measure whether it has done or not. That's not the case for things like hallucinations. If you take part in a trial of something that's meant to address one of the symptoms, that can be quite quick. Does it work or not? So some trials for Parkinson's will be quicker than others, but on average, you look at maybe taking a drug for 16 weeks. You've got your recruitment into the trial. Obviously, not everyone can turn up to the trial site on the same day and start taking the drug. You drip feed people over a period of time. You have to do the assessments and get them out the other end, and then you start with your next. So everyone's always moving along the trial system. So on the start date, you're not looking to end the trial exactly, say, 16 weeks after. That's just when your first patient will end. And then you've got the whole. So if you're doing a trial of 50 people, just getting them into the trial can take months as well. So yeah, it's normally year, 2 years to do a phase 2 trial. You then have to write up your results, which include all the safety assessments before you can progress to a phase 3 trial. Now, a phase 3 trial is all about the benefit of a therapy, and there are 3 trials basically. 3 phases of trials that we need to really concentrate on. But your phase 3 is your big, many, like possibly hundreds of people taking part in a trial for enough time to actually show that the drug does what it's meant to do. So for Parkinson's, that might be quite a considerable length of time. For the GDNF trial, for instance, how many weeks was that? It was like 30 weeks or something that people took that. and then there was an extension on top of that. So yeah, it can be 5 years or so before you even get the results out of a phase 3 as well. That is mostly because Parkinson's is hard to measure, and if you're trying to measure progression, you do have to do it for a while.
Has the situation of COVID, with obviously long COVID, has that helped the Parkinson's side of things at all? Because I know they're looking into long COVID now and a lot of chronic conditions. Will that have any impact on Parkinson's and help in research, or money thrown at Parkinson's to help at all?
At this point in time, not obviously. No. There's obviously quite a lot of financial difficulties in the UK at the minute, so I don't think there's going to be a sudden flood of extra funding for Parkinson's. And also, we don't know. I don't think there's enough evidence that the COVID symptoms are related to Parkinson's in any way that will benefit research. By doing research on long COVID, we'll also see a benefit for Parkinson's, for instance.
My mum had Parkinson's at the beginning of September last year, and she's declined rapidly since having it, you know. So
yeah. And I think that's true of, there are other types of viruses that can also cause that. It's the extra stress on the body and the brain cells and everything else can exacerbate long-term conditions, and that's not just Parkinson's. It's viruses can do that to other conditions like diabetes and heart conditions, things like that. Yes, so I'm not entirely sure, but fortunately we're making progress in other areas. So whilst the government might not be sending us more money, one of the things Parkinson's UK is doing is we are, like, biotechs are always making new drugs. Great. Parkinson's is a hard condition to make new drugs for, but if we're a charity, we don't have to be, we don't have to make money based off of our research. And at Parkinson's UK, we employed a few years ago, we encouraged our director of research. He's called Arthur Roach. He has a pharmaceutical background, used to work in big pharma. He now works for us, and he brought with him the know-how of how to do drug discovery and development and clinical trials in a pharma background, and has basically set that up for a charity to work in that way. But when we don't have to make money back for our shareholders, we don't have shareholders. We don't have to be focused on where the money is. We can be focused on what people will benefit from, what people with Parkinson's need. So we now have something called the Parkinson's Virtual Biotech, and we are working like a pharmaceutical company to develop new treatments. So you'll probably be hearing quite a lot more about that, because a lot of our research is going through that way now. And it's actually quite exciting because we can speed up research into delivering new drugs and make sure that we are investing in the areas that are going to change people's lives, rather than just waiting for the academics to push that way forward. We can make sure that we are pushing for progress to be made. The hands up in the room again. So
I wanted to know, do you know if there's any research being done into the effect of protein, and with, as you know, for some people, protein really affects the absorption of their medication. When it does, it can be quite profound. So I wondered if there's any research being done into that.
I don't know of any research. It's quite a well documented. It's well documented. We know that if you have a high protein meal and then you take levodopa-based medications, that they are unlikely to be absorbed as well. We know that so much that actually it's part of the recommendation when people are given drugs, that they are spoken to about diet and about how that you can mitigate against those things.
The only thing I would say is that communication, I don't know, maybe it's just we were unlucky, but it took, even though, because they say, don't they, to eat within a certain amount of time of your medication, and even though we did that, we found that then, even if you had any protein, it still had an impact. And but he'd been struggling for a long time. It was only we worked that out ourselves. The consultant and the nurse, neither of them had suggested that might be an issue. So it's just it's very, very profound. And I just wondered if there's any chemical research that might actually may be done into that, because it's very it's a very tricky thing to try and manage when it does affect you.
So I don't know that there's research going into it. We know why protein has that effect because it's where the levodopa is being absorbed in the body, and different drugs are absorbed at different points in the gastrointestinal tract. So some are more affected by protein than others. Unfortunately, Parkinson's is absorbed in the area that most protein does have a big effect on. I think it's more of a communications problem, and getting these types of handy little hints out to people that actually
if they could mitigate that, that would be much better than just just trying to manage. What I'm saying is trying to manage it is still very difficult, and I just if there was anything that could be done from a chemical point of view.
I mean, I know how there are drugs that reduce the absorption, and that would be exactly the opposite of what you want. There's also issues in Parkinson's with gut mobility, and the fact that things like constipation and things like that can also have an effect. So some of the drugs, not specifically looking at protein issues, but looking more generally at digestion and improving those types of things, might have a more chance of having an effect. It's always tricky because if you take another drug to affect how your body absorbs protein, that's probably going to have other side effects and even more drugs on top of what people are already taking. So some of the best advice I've heard is things like exercise can get things moving. If you're constipated, you're not going to be absorbing your drugs on time. It's going to take longer to go through your system. It's going to be a delayed response to that. So things like exercise can get things moving. So going for a short walk before you take your medication, not as easy as it sounds, because occasionally you need your medication to take the short walk, but things like that people can try. And yeah, the tricky thing is with diet, particularly drugs that affect how you absorb different things cause all sorts of side effects and aren't great in the long term. So when you've got a long-term condition like Parkinson's, you don't really want to be playing around with that. Any other? Now, I don't remember what time I was meant to finish, but I know I've been talking a while. So,
well, I think we would normally come to close around now. So I don't know if there's anybody else who's got any burning questions. Or you want to answer? Okay, my husband wants me to ask one, which I haven't asked you, so I'll ask you now. He heard on the radio the other day, on Radio 4, they were talking about the placebo effect. And they were also mentioning that one of the conditions where it's very significant is in Parkinson's. And so I think he didn't really understand that, and wanted to get if you could explain that a bit better.
Okay, so placebo effect is one of these magic things where if somebody you believe says, here's a pill, it'll take away, it will do something, your brain convinces you that it's done that. So there are things like researchers that have looked into the placebo effect know things like if you take a red pill that's got nothing in it, it's just a red empty pill, and you tell somebody this will help your pain, it will have a benefit. It will be more beneficial than a blue pill. If you give somebody an injection of just water or saline, it will be more effective than an empty pill. If you give people 5 pills that have got nothing in them, it will be more effective than a single pill.
And why is it, we know what the placebo effect is, but why is it a thing in Parkinson's in particular?
Yeah. So it's obviously your brain doing something. Now, Parkinson's is to do with dopamine. Now, dopamine has other effects on the brain, and one of them is to do with reward and the side effect of some Parkinson's medications, mostly dopamine agonists. It can have an effect on how people respond to reward and can cause things like gambling issues or online shopping addictions, things like that. Now, dopamine also seems to be involved in how the brain responds to outside cues, basically. So if somebody is telling you that this is going to have an effect, your brain is turning that knowledge into chemicals inside your brain, and we're not entirely sure what causes the placebo effect, full stop. We don't really understand it. If we understood it, we would do clinical trials where placebos weren't a problem, because we would sort that out. Instead, we have to do placebo-controlled trials where we have some people taking empty pills and some people taking the actual, because we can't control for it. But it seems to be something to do with the change in balance of dopamine and other neurotransmitters, like the knock-on effect of dopamine being changed seems to affect those chemicals in the brain and just makes people even more affected by the placebo effect. So if it just means that clinical trials in Parkinson's are even harder to do because your placebo group always sees a benefit. So when you're testing a new drug and you're hoping to see whether it works, if people are taking a placebo drug and it works, well, there's going to be less of a difference between those two groups, and it always causes issues. But ultimately, we don't understand what causes the placebo effect. We just know from prior experience, placebo control groups in Parkinson's see a much higher benefit than placebo groups in other clinical trials.
Very interesting. Any other burning questions from the hall? Look, or any other questions online for Becky? Is there any other? Is there anything else you particularly wanted to cover, Becky?
No, I mean, I can talk for hours, but I feel that people would like to go get a cup of tea and have a break now. You've heard enough from me, so.
She's excellent.
Yeah, brilliant. Oh, that's been really, really interesting. Thank you very much for answering all our questions. And maybe we'll come back again another time and talk to us again.
Yes, certainly. And it's been lovely to see you all, and well done for doing a hybrid meeting. It is challenging, and that is the first time I've seen a roaming camera. So that is, that deserves, I don't know, a 10 out of 10 and a write-up in the books.
Yeah, well done to David. Yeah, David's been in the corner not saying anything, but he did all the work. So well done to David. Yeah. Hang on, I'll show you David. Yeah, he needs his moment of glory. Hang on. There you are.
Shall we all give a...
There, David. Lovely. Well, thank you very much, Becky, and bye-bye, everybody, and see you next time. Oh, next time is going to be very interesting. We have somebody from Stroll Technology who's going to come and show us about some glasses that they're inventing. They're in their research phase, and they want to take feedback from people with Parkinson's. And they're glasses that can help if you freeze and you can't move. And these glasses are meant to help you overcome that. So it's going to be a very interesting session. That will be in August.
And remember, there's singing tomorrow.
Yes, singing tomorrow. Lovely. Thanks, everyone. Bye-bye. Bye. Thank you. Thank you.